Hello guys, welcome back to my YouTube channel. Today I'm going to solve day 21 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I'm going to solve problem number 1971. Find if path exists in graph. Okay, so in this problem we have given a bidirectional graph with n vertices where each vertex is labeled from 0 to n minus 1. Okay, so here total number of vertices are 3. So see the numbering of these vertices, these are from 0 to n minus 1, 0, 1 and 2. Okay, the edges in the graph are represented as a 2D integer array edges where each edge denotes a bidirectional edge between the vertex u and vertex v, and every vertex is connected by at most one edge and no vertex has an edge to itself. And we have to determine if there is a valid path that exists from vertex source to vertex destination. So source and destination is also given to us. Okay, and we have to find whether there is a path exists from source to destination. Okay, so see here in this particular example, n is 3, so we have vertices 0, vertices 1 and then one more vertices 2. Okay, and these are the edges. So 0 is connected with 1, and this also means that 1 is also connected with 0. 1 is connected with 2, then 2 is also connected with 1. 2 is connected with 0, 0 is also connected with the 2. This is a bidirectional, right? So from 0 we need to go to 2. Okay, so there are two paths from vertex 0 to vertex 2. Okay, from 0 to 1 and then 2, this is one path, and there is one more path directly from 0 to 2. Okay, so total two paths are there, but in the output we have to just return true if the path exists, otherwise we have to return false. Okay, so today I am going to solve this problem using DFS first. Okay, so in total I'm going to use three approaches. Okay, one is DFS, then after that I am going to solve this problem using BFS, and then in the end I am going to use union find data structure. Okay, so all these three approaches are important. Okay, and you guys can solve this problem using any of these approaches. Okay, but if you watch this video till end and clear with all the approaches, then definitely many of your doubts will get cleared. Okay, so it's good to know all the methods. Okay, it's good to know about DFS, it's good to know about BFS, and it's good to know about union find data structure. Okay, so I hope that you guys are going to watch this video until end and trying to solve this problem using all the approaches. Okay, all three approaches. Okay, and because this is going to be beneficial for you in solving the problems related to graph or queues or anything. Okay, so please watch this video until end. Okay, so first let's solve this problem using DFS. Okay, so first of all what we need to do here, let me copy this example. Okay, example 1. So okay, so this is the example 1 given to us. Okay, so first we are going to create one adjacency matrix. Okay, so I am going to treat all the vertex. Okay, so I am going to treat all the vertex as key. Okay, and if they are connected with any other vertex, then I am going to denote them as values. Okay, so simply I am going to create one map. Okay, and in map we have one key and one value. Okay, so here this 0 is connected with 1. Okay, so first of all we are at this position. Okay, let's say we are at this position and first edge is 0 to 1. Okay, 0 is connected with 1, and since this is a bidirectional graph, so I can also write it like this: 1 is also connected with 0. Okay, this is key and this is value. Okay, then after that when I reach here, so it's saying that 1 is connected with 2. Okay, so 1 is already exist in my map, so here I am writing 1 is connected with 2. Okay, and 2 is also connected with 1. Okay, so I am going to write it like this: 2 is also connected with 1. Okay, this is done. Then here it is saying that 2 is connected with 0, so 2 is connected with 0, so I am going to write it like this, and this also means that 0 is also connected to 2. Okay, so I am going to write it like this. Okay, so first of all we are going to create this adjacency matrix. Okay, and this thing is common for both DFS. This thing is common for both DFS and BFS. Okay, so first of all we have to create one adjacency matrix AM. Okay, so let's do one thing. Let's write the code for this adjacency matrix first. then I will show you how we are going to implement DFS and then BFS. Okay, so first, this is common thing, adjacency matrix. So let's write the code for this one. Okay, so I hope that you guys are clear what I'm doing here, right? So this is a function given to us. Okay, this is a method valid path. So here, first of all, we are going to check if our source is equal to our destination, then definitely we have to just return true. Okay, this is one base condition. So here I am writing if my source is equal to destination, then in that case we have to just return true. Okay, this is done. Okay, then after that we have to create one map, and in a map you can see this is my map, right? So here we are storing integers, right? And here we are storing list of integers. Okay, so this is one list. Okay, this is a list of integers. Okay, so step by step I am also explaining, right? So here I am going to create one map in which my keys are going to be of integer type. That is why I am writing it like this, and the values that I am storing, they are forming one list. Okay, list of integers. So I am going to write it like this, list of integer. Okay, let's name it as map new hash map. Okay, this is done. Then after that I have to iterate over these edges one by one. Okay, so first I'm going to this edge, then after that I'm going to this edge, then after that I'm going to this edge. Okay, to create this adjacency matrix I have to iterate one by one. Okay, so I am using one for each loop. Okay, and in for each loop I am passing this one by one. So let's name it as vector. Okay, VEC. Okay, something like that. BC, this is VC, this is VC. Okay, one by one I need to go. So first I'm here, then after that I need to go here, and then after that I need to go here. Okay, so first let's go to this position. Okay, so I'm using one for each loop. This is one array, right? Int vec, and I am iterating over these edges, right? This edges 2D array. Okay, so I pick just one array. Okay, in this. So I hope that this is clear. Okay, and in this particular vec there are two values. Okay, so let's name it as u, name this value as u, and let's name this value as b. Okay, so here I am writing int u is equal to vec of 0. Okay, so this is clear, right? Side by side I'm explaining, right? Int v is also equal to vec of 1. Okay, so this is clear. This is 0th index, this is 1 index for this vec. This is 0 index, this is 1 index for this vec. This is 0 index, this is 1 index for this vec. Okay, and one by one I am iterating, right? So here I am picking u and v. Okay, and then we have to put the values like this. Okay, so if 0 is connected with 1, okay, so I am storing two keys now. 0 is connected with 1, and then this also means that 1 is also connected with u. Okay, okay, that is why I'm writing it two times. 0 is connected with 1, 1 is connected with 0. Then 1, 2, that simply means 1 is connected with 2 and 2 is connected with 1. Then after 2, 0 means 2 is connected with 0 and 0 is connected with 2. Okay, so we have to write two times, right? From this u to v, and then we have to write from v to u. Okay, so two times we are writing, right? So for that I have to write it like this: map dot compute if absent. Okay, this is one map function. Okay, in this map function we are going to check if our key is available. Okay, if our key is available, then what we need to do, then we have to just add the value of v. Okay, if our key is available. But if our key is not available, if key is not there, then we have to create one array list. Okay, so here comma k, this new array list. Okay, so I hope that this thing is clear, how we are writing this compute if absent function. Okay, okay, this is done. Okay, so this is a very simple, right? We are checking first if this key is there. If this key is there, then we have to just add the value. Okay, so initially let's say initially keys are not there. Okay, this is my key value and initially keys are not there. Then we are creating one for 0, we are creating one array list, and then after creating the array list, then we are adding the v is 1. Okay, and same way, one key was not there, then we are creating one array list, and then we are adding the v. So opposite direction right now, so from v to zoo. Okay, so I am adding 0 in the next time 1 to t. So one key was already there, right? So here we don't need to create array list. Instead of this, we have to just add 2 here. Okay, so I hope that this is clear. Okay, same way, this is the step when our key is u. Okay, same way we have to make v as our key, right? So here 0 to 1 and 1 to 0. Okay, zoo to v to zoo, right? So 2 keys. So here I am going to just make it a little bit change. I am going to make it v, and here I am going to write zoo, right? This is done. So I hope that you guys are clear. So we have created adjacency matrix like this. Okay, so this map will have all the keys and their adjacent values. Okay, one vertex, and this vertex is connected to these two vertices. This is vertex and this is connected to these two vertices. Okay, so this is done. Then also one more thing, see here, if I am going from 0 to 1, okay, I need to go from 0 to 2. Okay, so here if I go from 0 to 1, so 1 is also connected with 0, but do I need to visit this 0 again? Then if I visit this 0 again, then again I move to this position, then again. Okay, so this is going to show one cycle. Okay, so I don't want to move from 0 to 1 and then again back to 0. So if I have already visited one node, one vertex, okay, then after that I have to mark this as visited. So I'm marking this visited, I'm just writing it true. Okay, then after that I move to this vertex, I am going to mark it as visited, so that after that I only move to the non-visited node. Okay, so this thing we need to take care. Okay, so from 0 to 1, after that I don't want to see here, I go to 0 to 1, but this is my source, right? We have to start from this. Then after that I need to move to 0 to 2 now. I don't want to backtrack again and again, so this will completely form one infinite cycle, 0 to 1 and then 1 to 0. Okay, so we have to take care of this. So every time when we are in vertex, we have to mark that as visited. Okay, if we have visited that vertex. Okay, so for that I have to create one array, boolean array, boolean visited, spelling mistake, boolean visited is equal to new boolean. Okay, and this is done. Okay, and in the end we have to just return one method. Okay, in this return I am calling for this check method. Okay, in this check method I am going to pass my map, my source, what is my destination, and what is my, and whether I already visited this node or visited this vertex or not. Okay, so I am going to call for this. Okay, I am going to call for this. So here this is simple process for creating this adjacency matrix. Okay, so now let's say what I'm going to do for the DFS. Okay, so now I have to explain what I'm going to do for this DFS. Okay, so this is a key value. Okay, so first what I'm going to do here, I am at this position. Okay, key and values. Okay, these are given. So our source is 0. Okay, so first of all I'm going to use black color pencil. Okay, so first of all I am at this position. Okay, zoo. Okay, at this position 0. Okay, then after that I go to this vertex. Okay, I'm going to mark this as visited. Okay, so I'm going to mark it as true, I have already visited. Then after that I go to this vertex 1. Okay, I go to this vertex 1. Okay, and then after going to this vertex I have to check for the values for this vertex. Okay, this one. Okay, from 0 to 1, and from 0 I go to 1. Okay, because this is in one of value, right? This 0 is connected with 1. Then after that in for 1 I'm going to search. Okay, after that for 1 I'm going to search. So 1 is connected with 0, but since 0 is already visited, Okay, so I am not going to visit this 0. After that I am going to visit this 2. Okay, but right now see, 0 to 1 and 1 to 2. So we have found our destination. This is my source now. 0 is my source, 0 is going for 1, and then in 1 I am searching. So in 1 we have got this 2, and 2 is my destination, so we have to return true. Okay, so I hope that this thing is clear. Okay, so from this 0 I go to this 1. Okay, this one is in my values. Okay, 1 and 2 both are in values. So first I am going for this one, and then in 1 I am going to search. In 1 we have two values, 0 and 2, but I don't want to search for this one because this is already visited. This 0 is already visited and this one is also visited, but 2 is not visited, right? So from 1 I go to this 2, and this 2 is equal to my destination, so I have to return true. Okay, so this is how we are going to implement the DFS from 0 to 1, and then in 1 we are going to search. 0 is already visited, we go to the 2, and then 2 is equal to destination, so we are going to return true. That's it, right? Simple. So here let's declare this method. Okay, so here public boolean check, and in this check method, okay, we have to pass our map, this map. Okay, let me copy it. This map we have to pass, then we are passing our source and destination. Okay, so let me copy this source and destination. Then after that we are passing one boolean visited, right? This array we are passing, right? Boolean visited. Okay, so let me change this name to node. Okay, so that you guys don't get confused. And this destination I can say it DST. Okay, okay, this is done. Okay, so this is done. Now after that, inside this we have to check. I am calling for this method, right? This method. So here we are passing one source. Source is nothing but our node. Okay, so if our node is equal to destination, then we have to just return true. Okay, so here I am just writing return true. Okay, this is done. Then after that I am going to check if I have already visited that node. Okay, if I have already visited that node, if I have visited the particular node, then in that case I have to just return false, because after that I don't want to search anywhere. Okay, if I have already visited the node. If I haven't visited that node, okay, if I haven't visited our source yet, then I have to first mark this as visited. Okay, so here I am writing it as visited of node. I have to mark this as true. Then after marking this as true, then after that I am going to iterate. I am going to, after marking this as true, then I have to iterate over these values. Okay, one by one. So here I am writing one for each loop for int iterate, and in the map, okay, map dot get or default. Here I have to pass search for one key, right? Here I am searching for the keys. These are the keys, right? Node, this is my source, and for this source I need the values. Okay, so here I am writing it like this: map dot get dot default this node. Okay, if this node is available, then definitely I am going to get these values 1 and then later on 2. Okay, but if these values are not there, then that is why I am using writing get dot default, and here I am just going to pass one empty array list. Okay, new array list, so that it doesn't give any error. Okay, int array list. Okay, this is done. Then after that, inside this I am going to check if I haven't visited uh, this particular 1 or this 0. Okay, I have to write it like this: if not visited this it, and then again call for this method check again call for this method, check map, and this time this source is going to be my IT. Okay, this iterator, okay, this one, okay, and then in one we have to search, right? So here I am passing it destination is going to remain same, destination, and visited. Okay, so if this is the case, then we have to just return true. Okay, and if we haven't find anything, okay, if we haven't find here anything or here anything, okay, then in the end we have to just return false. That's it. Simple, right? Simple. Now let's run the code and see. So there is one spelling mistake, so let me correct it. Now let's run it. So all the test cases has been accepted. Now let me submit it. So see, our solution is accepted, right? So we have completed approach 1, and in this approach 1 we are using DFS, right? So here quick recap. First we are checking if our source is equal to destination, then we are returning true. Then we have created one map. So here we are just going to create one adjacency list. Okay, so this is what we are creating, right? This is thing. So we have created this. Then we have to keep track of the visited vertex. Okay, then after that we have to call for this method, and in this check method we are again going to check if node is nothing but our source. Okay, but our source that we are passing, if this is equal to destination, then we have to just return true. And if we have already visited this node, okay, if we have already visited this node, then we don't need to visit it again. Okay, then we have to just return false because we can't do anything. But if we haven't visited it, then we have to mark this as visited, and then we have to search for these values 1. Okay, so here I am going to use one iterator, okay, for each loop, and in this we are going to get one value. Okay, so first I pick this one. So if we haven't visited this one, yes, so this is condition is true, and then again I am calling for this method, and in this method my IT is 1. Okay, so for 1 I am going to check 1 is equal to destination, so it is not equal to destination, so we are going to okay, so after that it is not equal to destination. Okay, so we don't need to do anything. Then we are going to check if 1 is visited, so 1 is not visited, then we have to mark this 1 as visited. So I mark this 1 as visited, so it is true. Then in the 1 I have to check for this 0, but 0 is already visited, right? So that is why I have written this condition, right? So we don't need to execute 0. Then after that I pass this 2. Okay, so when I pass this 2 in IT, then again I call this method. Okay, so here our node is 2 is equal to destination is also true, so I'm just returning true from here. That's it, right? So we have returned true. So I hope that you guys are clear with this DFS approach. Okay, and the time complexity for this problem is going to be of v plus e. Okay, number of vertex, how many number of vertex and number of edges. Okay, so of v plus e. So since we are going for each vertex, okay, one by one. Okay, in this map we are checking for each vertex, and then after that we are going to find all the edges. Okay, wherever this vertex is connected to other vertex. Okay, so you can say the time complexity is equal to O of the vertex plus number of edges. Okay, so I hope that this is clear. So this is a approach using DFS. Okay, so DFS done. Now after that we have to see how we are going to solve this BFS. Okay, so in BFS also we have to implement same approach. First we have to create one adjacency matrix, then after that we have to use the queue. Okay, so you guys already know that for BFS we use queue only, right? So we have to create one queue. Okay, and in this queue first we have to what is our source? Our source is 0, right? So we have to pass this our source in the queue first. Okay, after passing this source, okay, we have to mark this source as true. Okay, we have to mark this source as true. Then after that we have to check our queue is empty or not. If our queue is not empty, then we have to remove this element. Okay, remove this element, right? this, we have to pick this element, or you can just say, yeah, let's say that you have to pick this element. Okay, we have to check if this element is equal to our destination. Destination is nothing but 2, so it is not equal to our destination. Then we have to iterate over these vertex. Okay, these vertices values. Okay, so we have to, one is visited or not, one is not visited, so I have to add 1. 2 is visited or not, 2 is not visited, so I have to add 2. Then for this one we have to check, so we have to just poll this value. Okay, q dot poll. So after polling we have to check this one is equal to destination, so it is not equal to destination, so we have to just pass the future values. Okay, one is connected with 0, 0 is visited. Okay, 0 is already visited, so we don't need to add. Okay, and 1 is also connected to 2. Okay, so here I am adding 2. Okay, this is done. Then after that we have to remove this. Then we have, after that I'm going to search if this value is equal to my destination. Yes, this is equal to my destination. Okay, then in that case we have to return true. Okay, return true. Okay, so I hope that this is clear. So simple queue we are going to use. Okay, so code is going to be very simple for this one as well. Okay, so same way here we don't need to call this one. Okay, let's simplify this. We don't need to call for this method. Okay, simple in one method. I will explain how we are using this queue. Okay, so here this is done. We have created one boolean, a visited new boolean. Okay, then after that we have to create one queue. Queue of integer queue new linked list. Okay, and in the first, as I have told you, we have to pass the source in my queue. So queue dot offer, and here I am passing the source initially. Then we have to mark this source as visited. So visited of this source, we have to mark this as true. Okay, then after that we have to run one while loop, and in the while loop we have to execute it until my queue is empty. Okay, queue is not empty here. Okay, and then inside this I have to pick one node. Int node is equal to queue dot poll. Okay, and now after that I am to check if my node is equal to destination. If my node is equal to destination, then we have to just return true. Okay, and after that we have to run one for each loop. We have to iterate. Okay, so same way map dot get or default. Here for this particular node I have to obtain the values. Okay, for this particular key, if there is no value, then we are just creating one empty array list. Okay, new array list. Okay, this is done. Then after that we have to check if we have not visited this node. Okay, visited this node. Okay, if we haven't visited it yet, then we have to mark it as visited. Visited of it, we have to mark this visited as true. Okay, then we have to add this in our queue dot offer. Okay, it. Okay, so here simply what we are doing. Okay, so let's understand it. So these are key values, right? So 0 is showing 1 and 2, right? And 1 is showing 0 and 2. Okay, so and 2 is showing 1 and 0. So simply you don't have to do anything here. You just have, what is your source? So this is my queue, right? So first you have to add your source. So source, I have added this source 0. Then we haven't visited it yet, right? We haven't visited, we have to mark this as true. Okay, we have to mark this visited source as true. Then we have to poll this 0, and this is not equal to our destination. Then we have to iterate over the values. Okay, so first I am going to pass 1. First value is 1. We haven't visited it yet. We haven't visited this value 1 yet. So what we have to do, we have to mark this 1 as true, and we have to add this in queue. Okay, this is done. Then after that I go to this position. We haven't visited this 2 yet. Okay, I haven't visited this 2 yet, so I have to mark this 2 as visited. Okay, okay, so I have to mark this 2 as visited, and this is true. Okay, and I have added this in queue. Okay, then after that I am going to poll. Okay, I have poll this element. Okay, I have polled this element, and this is node is not equal to destination. We have not equal to destination, then I have to iterate over the elements. So I have already visited 1. Okay, I have already visited 2. Okay, I don't need to do anything. Then after that I have to poll this element. Okay, then after polling this element, we are going to check if this node is equal to destination. This is equal to destination, then we have to return true. That's it, right? Okay, so this is done. Now after that we have to just return false. Okay, return false. Let's run it. Visited of it is equal to true. Spelling mistake. Let's return. So all the test cases has been accepted. Now let's submit it. Okay, so see, our solution is accepted. So I hope that you guys are clear. Okay, so let's do one thing. Let's do one thing here. So let me copy this code. Okay, so this is our code, right? And 0 is connected with 1 and 2. 0 is connected with 1, 2, and 1, 0, and 2, and 2 is connected with 1, 0. Okay, so here see, we are creating one queue first. Okay, and in the queue we are adding my source is nothing but 0. So I have added this source, and then I have to mark this as true. So I have marked this as true. Then my queue is not empty yet, so I have to remove this element. Okay, node is equal to queue dot poll. So I have removed this element. 0 comes outside, and then I have to check if this 0 is equal to destination. It is not equal to destination. Then after that I am iterating over the values. Okay, all these values 1 and 2. Okay, I haven't visited this 1 yet, so I have to mark this 1 as visited, and I have to add it in my queue. I haven't visited this 2 yet. Okay, so I have to mark this 2 as visited, and I have to add it in queue. So this is also true, this is also true. Okay, then this is done. Then again my queue is not empty yet. Okay, so then after that I have removed this element. Node is equal to queue dot poll. Okay, I have removed this element. 1 is not equal to my destination. So after that I have to iterate over the elements of 1 and 2, but I've already visited all the elements of 1 and 2, so I don't need to do anything here. Okay, I don't need to do anything here. Then after that I have to remove this element 2. Okay, so this 2 is equal to the destination. Okay, so we have to just return true. That's it. Okay, that's it. So I hope that you guys are clear with this queue code. Okay, this BFS code. Okay, so here same way. Now we are done with both DFS and BFS. Okay, so now let's try to solve this problem using our final approach, that is union find data structure. Okay, so we are done with both DFS and BFS. Okay, so for BFS, for this union find data structure, what we have to do here, let me copy this example. Okay, so this approach actually it's going to be little bit different from previous two approaches. Okay, so first of all we have to initialize for to solve this problem using union find. Okay, to solve this problem using union find data structure. Okay, so we have to first initialize one parent array. Okay, so how many the number of vertex are there? 3. Okay, so from 0 to 1 and 2. Okay, so we have to create one parent array. Okay, we have to create one parent array, and in this parent array each vertex is its own parent initially. Okay, so 0 is pointing to 0, 1 is pointing to this one, and 2 is pointing to this 2. Okay, so let's say this 0 vertex is at 0th index, this one first parent is at this index, and this second parent is at this index. You can say something like that. Okay, so each vertex is its own parent initially. Okay, this is done. Then after that we have to iterate over our edges. Okay, so we have to merge the sets based on the edges. So this is one edge. Okay, 0 to 1. Okay, so first 0 and 1. Okay, we have to do the union of 0 and 1. Okay, I have to pick this u and 0 and 1, and I have to do the union of this 0 and 1. So tell me here, what is the parent of 0 initially? So parent of 0 initially is 0 only, right? So I am writing it in the red color. So parent of 0 is 0 initially. And what is the parent of 1? So parent of 1 is 1 initially. So I am writing it 1. Okay, so this is done. Now both 0 and 1 has different parents. Okay, so what I am going to do, I am going to make the parent of my 0 equal to v. Okay, so I am going to make the parent of this 0 as v, as this v1. Okay, because we know that 0 is connected with 1 and 1 is also connected with 0. Okay, we know this thing. Okay, so here from here we know that 0's parent is 0 and 1's parent is 1, but we know that this is one edge only. Okay, so if both the parents are different, then for the first edge, okay, for the first one, okay, for first one I have to update its parent to the this one. Okay, second one. Okay, so u and v are given. Okay, u and v. Okay, so I have to update the parent of u just like 1, just like v. Okay, if the parents are different. Okay, this is done. So now 0's parent is 1. Okay, so I have to change it to 1. I have changed it to 1. Okay, then after that I go to this edge 1 and 2. Okay, so I am going to check what is the parent of 1. Okay, so parent of 1 is 1 only, and what is the parent of 2? Parent of 2 is 2. So both parents are different. So here this is u, this is v. So I have to just update the parent of u to v. So now I have to make the parent of this 1 as to 2. Okay, same way last. In this case what we did, we are going to just perform the same condition, because we know that 1 is connected with 2 and 2 is connected with 1. Okay, so I have just make the parent of this u as 2 only, just like v. Okay, this is done. So here this value is 2. Then after that second edge is 2 and 0. Okay, 2 and 0. So now just tell me what is the parent of 2. Parent of 2 is 2, right? And what is the parent of 0? So parent of 0 is nothing but 1, right? And what is the parent of 1? 1's parent is nothing but 2. Okay, so in the end both 2 and 0 have the same parent. Okay, both 2 and 0 have the same parent, so we have to just return the true. Okay, so in the end we have to just find the parent of our source and our destination. Both have the same parent. Okay, now in the end, so we have to just return true. Okay, so this will be more clear when I'm going to write the code, but I hope that you guys are clear what I'm doing here. Okay, so now let's write the code. Code is going to be very different. Okay, little bit complex but very different than our previous approach. So let me discard all the changes. Okay, so step 1. So I am going to write to the step 1. Step 1 is nothing but initialize parent array. So I have to create one array. Okay, parent array. Int parent is equal to new int n, and then I have to make each vertex is its own parent, right? So for that just run one loop int I is equal to 0, I is less than n, I plus plus parent of I is equal to I. That's it, right? This is done. Then what is my step 2? My step 2 is nothing but merge sets based on edges. Okay, so I have to create the one set and we have to merge the sets based on the edges. So let's iterate over each edge one by one. So int edges, int u is equal to edge of 0 and int v is equal to edge of 1. Okay, and then we have to just perform the union between u and v. Okay, after we find the union, then in the end we have to just return the parent. Okay, so if return the parent, okay, so I'm going to use call one find method. Okay, so here we are going to check if source and destination belong to the same set. Okay, so for that I'm going to write it like this: find source is equal to find destination. Okay, this is done. Now let's define our union and find. Okay, so union operation. Okay, in union operation we have to just find. Okay, so what I have told you, so I'm going to write the same thing: private void union int u int v. Okay, so we are passing these two in our edge, right? Int u and v. Okay, so here u is this 0 and v is this one. Okay, that's what we are finding. Okay, we are calling from this method. Okay, so here once I pass this, then after that I have to find the root of u I have to find. Then after that I have to find the root of v. Okay, root of v. So here find, calling for this finding the root of u, and here I am finding the root of v. And here I have told you one thing, that if the parent is not same, okay, if root u is not equal to root of v, then in that case we have to just update the parent of u. That's what we are updating, right? Parent of u, I'm going to make the parent of root u same like v. Okay, because they are both are the part of the same set. Okay, this is what I did here, right? 0 is pointed to 0 and 1 is 1. Okay, both have different parents, so I'm making the parent of this u as 1 only. Okay, so that's what I did here, right? This is simple. This is the union operation to merge two sets. Okay, then after that let's define the find. Okay, so private int find int vertex. Okay, then here we have to check if parent vertex, if the parent vertex is not equal to vertex. Okay, then we have to find the parents. Okay, parent vertex. Okay, so here then we have to write parent vertex is equal to find of parent vertex. Okay, this is a path compression. Okay, then in the end we have to just return parent of vertex. Okay, this is done. Now let's run the code. There is some issue, let's fix it and let's see. Okay, private int find, where is the space? So let's run it again. If parent of vertex is not equal to vertex, what's the mistake here? Int find int vertex. If parent of vertex is not equal to vertex. Then after that we are updating parent of vertex is equal to find of parent of vertex, right? And what's the issue here? Cannot find symbol parent of vertex. Okay, let's see. This is private, and here we are defining it. Okay, let's do one thing then. Let's do one thing here. Private int parent. Okay, let me remove this and let's run the code now. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted. Right now see, the runtime is also very good. Yes, just 10 milliseconds and it beats 97.31% of users with Java, right? So I hope that you guys are clear with this problem. Okay, so this is the main thing that we are doing. Okay, u and v, if both have different parents, then we are updating the parent of u as v. Okay, because they are the part of same set, right? Same way, and in the end we have to just return true if our parent of this source is equal to the parent of this destination. Okay, so I hope that you guys are clear with today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye.